So yeah, as was said, I am a data scientist working at the British Museum, but I'm not going to be talking about any of that today, sadly. I am talking about a personal project related to literature and novels and the kind of fun stuff that you can do with them that is maybe a step away from traditional NLP stuff.
Harrison, we need the mic, sorry. We need to hear your lovely voice. Our natural language processors are not working. Our human ears don't work as well.
How's that?
Thank you.
Better?
Yes.
So, as was said, I am a data scientist working at the British Museum. I'm not going to talk about any of that, just going to go over some fun results related to novels and the stuff you can do with them. So, even though I have a background in machine learning, no neural networks, no machine learning, no nothing like that in this talk. Also, nothing useful for work. Hopefully you'll go away and have learned nothing that you'll be able to apply, but there's some interesting results in here. Hopefully you'll enjoy them. Who am I? I'm these things. You can at me in these ways. I did physics, I'm doing data science. The Bookworm story kind of starts with Infinite Jest, which is a massive, massive book with hundreds of characters and storylines that all kind of overlap. It's a very complicated beast of a novel to read, but there are lots of useful resources out there for people who are trying to attempt this thing, including this enormous map by a guy called Sam Potts, which is lovely. It's a map of characters. This was put together by hand by Sam, and all of these points are characters in the novel, and they are connected by their connectedness. If you see an edge between two characters, that means that they have some kind of relationship. And I found that when I was reading the book, I went back to this quite often to try and keep track of who was what and where and what they were related to, how important they were to the story. And I was thinking, can I duplicate that programmatically? Is there some way that we can take any novel and extract its characters and put together some big map like this? It's a potentially useful thing in a lot of ways if you're coming to a new novel, a big novel, or whatever. But it also gives you a nice, intuitive way of approaching graph theory, network analysis. It gives you a comfortable frame to explore all of these concepts in. So yeah, the idea is that we're going to go from this, or this, seeing as we're in the US, to something like that, which is a network of the Harry Potter characters. They are all kind of coloured by their grouping, which has also been automatically extracted. So yeah, the answer to the question is yes, this is doable programmatically. All of the code is here. You can go and find it. You can go and play with it. It's a lot of fun. So to start, we need to find connections between character names. That involves scraping a load of text from a novel and taking names. First, loading in a book is super simple. Code is on the screen. Anyone can do that. Passing in a list of names. The easiest way to do this is to pass an explicit list of names to explicitly tell Bookworm who the characters are in your novel that you care about. And then from there you can go and build this network. But it's not really automation. You can't really call that an intelligent program if you're giving it a load of context beforehand. I wanted a program that would automatically take in any novel and spit out this graph without any prior context or knowledge. So we needed to find implicit names or plausible names in a novel. I used a load of stuff from both Spacey and NLTK for this. But it's just a process that goes through every single word in the novel, works out whether it is a proper noun, whether it has a certain length, a load of very simple checks on each word to see whether they are a plausible character name, whether they look like something that might be a name. This kind of relies on authors' adherence to typical language yeah, typical English language, but usually that works in what I've found so far. The next thing to do is split the book into a load of short chunks. So we've got 3 versions of that splitting here. One that splits into sentences, so you might get a sentence like this. That uses NLTK. This one splits it into words, so you might end up with a sequence like this. Or characters. It doesn't really matter which one of these you choose. I usually go for sentences because that includes the most context, but you know, it's up to you which one you use there. And then this is the kind of secret behind Bookworm and how these graphs are formed. Basically, for every sequence, every sentence in the book, it goes through and checks for occurrences of character names. So in this example sentence, it might pick out that Vernon and Harry are characters, tag them, and then build up a table that looks something like this, that says for every character in the network, do they appear in each sentence and how many times? That ends up being an incredibly sparse matrix, but that's what we start with. From there, we build up an adjacency matrix or co-occurrence matrix by taking the dot product of that with its own transpose. So what we end up with after this, after taking the dot product of this with itself, is a matrix of character names and character names. So character names along the top and character names down the side, and the number of times that they co-occur in sentences. That gives you a measure of how related these characters are. And that's basically it. Once you have an adjacency matrix, you can do all sorts of graph theory stuff and network analysis. And that's where it all comes from. That can be trivially transformed into something that is interpretable by NetworkX, which is a fantastic Python library for network analysis and graph theory stuff. It takes stuff in this form, where you have a character source, a character target, and a value of the strength of the connection between those 2 characters. As I said, all of this code is on the screen, but it's also on GitHub, so don't worry too much about reading it all. So we can pass this table into NetworkX and visualize it very, very quickly with networkx.drawSpring, where spring refers to the idea that edges between characters, the connections are springs with a kind of springiness, a strength, related to that character connectedness, the value column there. So doing that, we end up with something like this, and there is our graph. We can see that it kind of makes sense. We have a cluster up at the top of the Dursley family. You can also see that the Weasleys are often clumped together. You might see that Voldemort is connected to Harry and Firenze and Ron. These things kind of make sense. That graph there is using the explicit name list that we manually input. We manually pass those names to the network. But this, again, very similar, has all of those same clusters, is done using the implicit names, so scraped purely using their plausibility. And yeah, it works surprisingly well. We can do this for any novel. I found it works on pretty much anything. So here's Harry Potter. Here is Lord of the Rings, which is quite a lot more complicated, but again, if you go and inspect that, it does make sense. Here is Pride and Prejudice. You can see that these networks are quite different to each other. Harry Potter and Lord of the Rings look much more similar. They have more similar features than Pride and Prejudice, which is a much more kind of incestuous network where everybody knows each other and it's a very small network, whereas this is a huge, sprawling epic. You can work out the closest relationships of each character to the rest of the network. So Harry Potter is most closely connected to Ron Weasley, Hermione, and Hagrid. You can work out the character importance of every character in the novel. So in Harry Potter, unsurprisingly, Harry Potter is the most important character. I did this with the Bible the other day. God, most important, apparently. Israel came second, which is interesting, and Jesus third. This is using PageRank. This is HITS, two different algorithms for assessing importance of nodes in a network. You can also find paths between characters. I don't know why this would be useful, but it's kind of interesting to think about. That maybe if you wanted to connect Hedwig and Nicholas Flamel, this would be the path that you would take between characters with the fewest steps. Yeah, that is the kind of basic stuff that you can do with a network like this. That's the fundamentals. Now we're going to move on to some more interesting stuff that is maybe more specific to novels, including time and chronology. Novels, or typical novels, take place chronologically. They're written down in sequence of how things happen. And you can chunk that up. You can say what happens in the first quarter of the novel, what happens in the second quarter, etc., etc., etc. Yeah, and through that you can watch the character relationships develop and get stronger, get weaker, and build up this network over time, which is quite interesting to look at. Temporal networks are a whole field that I'm only just starting to explore, but it's super, super interesting. And if you're interested in any of this, I would recommend going and looking at that. So this is Harry Potter chunked into 4. You can see that the first quarter of that on the top left is quite small, quite closely connected. Harry Potter's world is very small and sad. And then he gets to Hogwarts and his network expands, he meets more people, more things happen, and then things kind of close down at the end. This approach, where we're taking chunks of the novel individually and just looking at the first quarter by itself, the second quarter by itself, is one way of doing it, but we can also build up the novel over time. So take the first quarter, then the first half, then the first 3 quarters, and then the whole thing at once. And that's what this looks like. I think this is a much more interesting visualization. You can see that growth through the novel, which is very nice. You can do it into more chunks. It's all very interesting. Gender, stable marriages. I don't know whether anyone's heard of stable marriages or stable marriage problem. It's a problem that comes from game theory related to... the problem is taking a bipartite graph, so a graph with 2 types in it, and trying to match the different nodes in those 2 halves according to a list of preferences. So because we know the strength of the relationships between characters, we might be able to figure out who they would prefer to be matched up to. There is another version of this called the stable roommates problem, where you take a non-bipartite graph, just a singular graph with one type of node, and try and match everybody to one other person to maximize their preferences. So the approach that I have had so far to this doesn't involve actually extracting gender. I would really like to do that. If anyone has any tips on how to extract implicit gender or implicitly attach gender to a character name in a novel, hit me up. But I haven't got there yet. At the moment, I am just randomly assigning gender to each character and then matching. So occasionally Harry is a girl, but that's fine. Oh, that's sad. All right. Basically, this works. Half the time, you will get characters being assigned their correct gender. And in that case, Harry gets matched up with Hermione most of the time. That's nice. Yeah, the algorithm to solve stable marriages is called Gale Shapley. That's the pair of people who came up with it. I think this is going to show us, hey, marriages of Harry, Hermione. The last thing that I'm going to talk about, oh no, second to last, is community detection, which is a really interesting problem in graph theory. There's been a lot of talk on clustering and closeness today using neural networks and various approaches like that. This is a graph theory-based approach, which I think is really interesting, which I'm not going to go into detail of the maths of that, but it uses the Python Louvain module based on the implementation of Blundell et al. And again, it works. This is Infinite Jest. If you have read Infinite Jest, you know that the novel takes place in two kind of main storylines, and there are a lot of little adjacent storylines that go along with that, and that's what we see here. Two big clusters of single colours, and then smaller clusters of other colours around there. This is Lord of the Rings. I think this is the second book, because we've got Pippin and Merry and Treebeard and the Ents up there. Yeah, that's that. Here is Harry Potter. Again, you can see that the Weasleys are often clustered together, the Dursleys also clustered together. You also get teachers clustered together in this, which is nice. And yeah, finally, graph matching. So given that we can assess the similarity of characters in novels, I thought it might be interesting to try and figure out the similarity of novels to one another, not based on any of their language or their style or whatever, but just based on the shape of these networks that we've built. And the graph matching problem is a difficult one that is still being solved. But as I said earlier, we have these two networks, Harry Potter and Lord of the Rings, that are quite similar to each other in their structure, and then Pride and Prejudice, which is different. Using Laplacian spectra, we can do this. It works. Through this technique using Laplacians, we can calculate a score for each pair of novels, where the score's closeness to 0 is a measure of their similarity. So a novel matched to itself will get a score of 0 because they are identical, and a lower score gives a measure of more similarity. So here, with those three novels, we can see that Harry Potter and Lord of the Rings are more similar to each other. They are the more similar pairing. And Harry Potter and Pride and Prejudice, not very similar. Harry Potter and Lord of the Rings, again, not very similar. Through that, I'm hoping that we can build a network of novels. I really would like to take a huge corpora of novels that is the like of which is on Project Gutenberg or the British Library's Google Books or Microsoft Books thing, and ingest them all, bookworm them all, and pull out this huge graph of novels based on their character structure. I think that would be really interesting. Still in development. Don't know whether it's going to work, but if it does, I think we might be able to do some really interesting stuff. I have an idea about genre. I think that genre is probably extractable from this. The idea that we can assess the similarity of fantasy novels versus much more small character-driven ones. Yeah, and also there's an interesting thing that I've been noticing, differences between first-person and third-person novels. Quite interesting, because in a first-person novel, obviously the main character isn't named explicitly. You are I when you're reading a novel. That isn't picked up as a character name, so the character networks look quite different. But yeah, as I said, I am getting somewhere with the novel connectedness thing. Looking at all of the Harry Potters, we can pull out this heat map of similarity. Here the darkness of each cell represents their similarity. And by looking at all of them together, by essentially taking the sum of each column of that heat map, we can figure out which one is the most Harry Potter-y, if that makes sense. It's Harry Potter 2. Harry Potter 2 wins. Harry Potter 5 is the least Harry Potter-y book based on its character structure. That's basically it for what I've done so far, but there's a lot that can happen in the future. I reckon this is probably optimizable for HPC or high-performance computing. The finding connections is trivially parallelizable, I think. So if anyone wants to help with that, hit me up. And yeah, if that could be done, then we could apply this to massive stuff, or massive amounts of stuff. Again, clustering genres or types of novel, I think would be really interesting. The idea of applying it to historical stuff or biography, basically true novels, I think is another interesting application of this, being able to detect bias in the way that things have been written. Adapting it for screenplays, I think is also very easily doable. And yeah, classifying new novels, seeing which they are most similar to, and maybe coming up with some kind of recommendation system or algorithm based on that. Again, all of this code is on GitHub there. Come find it, come contribute, talk to me. That's it. Thank you very much. Any questions? Yeah, I'll go for the front.
Sure.
Mike.
Can you give the ELI5 on what Laplacian spectrum actually does?
Are you familiar with eigenvectors, eigenvalues? So you know that they encompass some sort of, when you do the singular value decomposition of a matrix, have you come across that kind of thing before? The SVD returns a sorted list of vectors based on the amount of complexity that each vector encompasses, if that makes sense. The Laplacian does a very similar thing. So what we're doing with the Laplacian where are we? Back here, is taking a taking the number of vectors which encompass 90% of the novel's complexity and then comparing them for two novels. I don't know whether that makes sense, but there is much more writing about this on GitHub. I can point you to that if you want more. Next question. There's another one right there. I think go for that just for the sake of Mike's simplicity.
Hi, I just have a question about source data. So obviously there's like Project Gutenberg and stuff for older books. Kind of where do you get data other than something kind of cost prohibitive like buying them all on Amazon and then converting the...
So I would recommend Project Gutenberg. It's a fantastic resource, and there is some really... there's more contemporary stuff on there than you might expect. I also mentioned the British Library and their resource that they have. That's all been OCR'd, and it was OCR'd about 10 years ago when computer vision was pretty nascent and not very good. So there's a lot of flaws in there. I'm still kind of exploring how applicable it is to that data set and whether we might need to do some more cleaning, stuff like that. But yeah, there are a surprising number of ways of getting hold of these resources. Yeah.
You have another question?
Thanks. So you had two graphs in the beginning for Harry Potter, one using the explicit names and the other one using the implicit names.
Yeah.
If I remember right, on the implicit ones, there were many more dots around the edge.
Yes.
Which I think means there's a lot more weaker connections.
So
can you talk about that, why there's that difference?
So the connections themselves aren't weaker. It's still finding the... Basically, I impose a threshold, a lower bound for the relationships that are going to be included. Let's go back to it. Here we go. So the difference here, I think, is mostly to do with the plausibility of those character names. The implicit names list also includes stuff like places. So Hogwarts might come up as a character in the implicit names, which itself is kind of interesting. It introduces a whole load of weird effects, like with particularly big novels like Infinite Jest or Game of Thrones, things like that. Geography starts to emerge from that because characters are all connected to places. Places are a certain distance from each other in this graph space. Yeah, I'm not really sure how to describe the weakness of those character names. It's definitely a problem that I'm interested in refining, but I think it's very interesting now, and the best way of getting to know it is to just go and explore, to apply this to a few novels yourself and get a feeling for what those might be. Thanks. One at the back.
Have you tried? I know you said you can extract genre from this, or you think you can. Have you ever tried this on something nonfiction, and then, like, is the plan to do that, and then like determine how realistic novels are? Or?
I don't know about assessing the realisticness, but I'm starting to think about how this can be applied to nonfiction, in particular biography, and maybe in situations where multiple biographies of the same person or multiple books about the same subject have been written, assessing the differences between them and maybe being able to determine what kind of slant each one has on that topic. Another idea I have is kind of similar, kind of different, but taking reference books and their indices, their indexes, and assessing the similarity of topics based on that, based on their proximity to each other in the index. That's something to explore. There was another question over here.
How informative do you feel that applying sentiment analysis to the sentences would be in determining the relationships between the characters, or do you feel like that would just be way too noisy?
Yeah, again, I think it's really interesting. I haven't done it yet, but I think it's definitely something worth exploring. I think the strength of Bookworm is that it doesn't do that. It has no idea about what sentiment is. It only assesses strength. So to go back to Harry Potter again, just because it's a nice illustrative example, Harry Potter might be as close to Draco Malfoy as he is to Ron Weasley. Even though it's an adversarial relationship between Harry and Malfoy, it is strong. If you're requiring that edges in the network have some measure of sentiment, I think that limits it, because there are going to be many fewer examples of sentiment in each sentence.
He just asked my question. So it was
Okay.
friend, foe, or lover.
Yeah, I, again, would really like to do that, but something that I'm still exploring for now. There's one down at the front.
Could you talk a bit about how you pre-process the data for analysis? Like, did you have to do anything to it? Tagging, labeling?
Not at all.
So the question was, how do you pre-process the data?
Yes, sorry. How much pre-processing am I doing in this process? Very, very little. That was the whole idea, was that I would just be able to slam this set of algorithms over any novel and output some kind of graph. I think the cleverest bit of pre-processing that goes on is part of speech tagging, which is, like you said, some kind of pre-processing thing, but that's left entirely up to Spacey at the moment. I'm not doing any of that myself, and it's a relatively quick process. So it's very labor unintensive for me.
Any more questions? We have time. So
One more at the front.
Lots of time.
Yeah, sorry, I know I
It's all right.
blasted through
You're
that.
concise.
Hi. More of an observation than a proper question, I guess. Have you thought about maybe applying the sort of genre, sort of specifying aspect of this, and thinking about trying to categorize things by when they're written or like publication date? Because like this kind of thing changes. Oh, I'm sorry, I'm a student of writing as well, so this kind of thing will often change over time. Like a Dickens sort of a novel will have a much more sparse matrix than something more written today.
So what I'm hoping is that that kind of thing will be emergent, that I won't have to tag things with their year of publication, that they will just cluster themselves. Whether that happens or not, I'm not sure. If it doesn't, I will probably go and tag a load of stuff with metadata, just to see whether things are clustering together or not. But yeah, that is something that I'm interested in. Historical trends, the way that writers from the 1800s compare to writers from the 1900s, and the way that character structure develops and audience's taste develops.
Thank you.
Do you do anything to make sure that you don't have like one node for Harry Potter and a different node for Harry?
No, not right now. It's a real problem with the implicit name network that often characters do have multiple names. With explicit names, it's very easy to tie those together. But with implicit names, it's quite hard to draw those relationships. But often those things won't matter with a lot of characters because of the threshold that is imposed. Usually they're only referred to by one name, and that name emerges as the strongest one, the one that has the most connections to the most people. So that's usually the only one that will be left in. It's only with very, very prominent characters in a network that kind of thing sticks around.
Harrison, what would the chart look like if it was the DC Comics? Because I feel like, those movie makers there's so many.
That would be interesting. I don't know how you would assess that. We would need to
how would you
integrate some
tackle
kind
that?
of computer vision to look for character co-occurrence in similar panels.
So I'm curious if you've thought about characters who aren't represented as proper nouns. So for example, in Cormac McCarthy, right, two of the main characters are the kid and the judge. And there could be entities in novels that are important, like an embassy or the union.
Yeah.
So how have you thought about edge cases like that and how you would deal with that?
At the moment, I am purely enjoying the fact that some non-characters are appearing in the network. So some entities, like you said, like King's Cross, might appear as a character in the network. Trying to automatically assess the characterness of a word that doesn't have these character-like attributes is difficult. If you have ideas about that, let me know. Yeah, very interesting. It kind of is a similar problem to the first-person, third-person novel thing. But that in itself is interesting, I think. It's worth exploring. Again, back.
You talked a little bit about splitting up the books into different sections and
Yes.
seeing how the network sort of morphed over time. Have you thought about maybe sort of doing it the other way around and having the morphing of the network sort of define what sections of the book are, or what lengths they are, and things like that?
No. Good idea. I'll go away and do that.
One last question? Okay. Excuse me. Thank you.
This might be the same as the question that was just asked, but as far as like symbols and places in books, think about some books that sort of are a little heavy-handed on the symbolism, and so you have objects that sort of matter more for their role in the story than just the individuals.
Yeah.
Have you thought about looking for, I guess, explicit symbols? The conch shell over the course of the book.
Yes. I haven't gone and explored specific novels with that in mind. I've just kind of noticed it in the ones that I have been working with. But that's a really interesting idea. I would like to grow this, apply it to more and more and more novels, and go and find examples like that. But at the moment, I haven't gone and done that explicitly.
Okay, thank you, Harrison, for sharing
Thank you
your
very
love
much.
of books and data with us.